A large, violent typhoon in the Pacific. A super El Nino also in the Pacific. Back home, things a little more typical for April. It's all in this week's Met Office Deep Dive. My name is Alex Deakin. Thank you so much for joining me. Thank you for being there. Thank you for watching. Thanks for your comments. Please do put them in the comments section. Any questions that you've got, we'll try and answer as many as we can during the deep dive or perhaps on our live broadcast on Friday. But welcome along. Deep Dive, we do this every Tuesday, an in-depth look at what's going on meteorologically close to the UK, but sometimes, like this week, further afield as well. Plenty to talk about. Do hit that like button, please. And, well, if you haven't done already, why haven't you hit subscribe? Join the 400,000 other followers. Let's get us up to 500,000 this year. That would be fantastic. So please do subscribe and share the love. Do you know another Met head that would like this kind of YouTube broadcast? Then, yeah, let them know about it as well. Get them to subscribe also. Yes, welcome along to this week's Met Office Deep Dive. More on this beast of a storm, Sinlaku, in the Pacific. And more on the UK's weather as well, which is, well, perhaps going to be the exact opposite of this, with potentially high pressure building in as we go into the weekend. A bit of uncertainty about that. More details on that to come. But first up, a big news story that's been steadily brewing over recent days and weeks. El Nino is developing in the Pacific. And earlier, I talked about it with Graham Madge. I'm joined now by Graham. Thank you very much for joining us. Graham Madge, do you want to tell everyone what your role is here at the Met Office?
Pleasure as always, Al, to join you. So my role here at the Met Office is I am a senior press officer leading on climate and also a climate science communicator.
Excellent stuff.
Fantastically privileged job to work here and cover those topics.
Yes, yes, and you do it so well. You've been on the Deep Dive before, of course, and many of our other bits of content that we put out. But today we're talking El Nino, which is in the news, shall we say, and that's kind of why you're here, because it is quite a big subject and is a growing subject.
It's come onto the news agenda rather abruptly in the last few days, so let's continue to talk about that.
Yes, exactly. So let's first of all deal with what El Nino is. Now, we're not going to go too much into the meteorology in this part. There is a full explainer video on our YouTube channel, one of our most popular videos of all time. So you can go and watch that. We'll put the link in the chat to that. So that tells you exactly what El Nino is. But here we're going to discuss the kind of context, what we could see, and what is happening right now. So this is a mapping of the sea surface temperatures in the Pacific, which is where El Nino occurs. And this is just to show the vagaries of El Nino, because it's not a regular thing, is it? It doesn't happen exactly every 3 years. There's an irregular pattern to the cycle between El Nino and La Nina.
It's one of the biggest patterns of climate variability that we see on Earth. And what you can see here are the red areas where sea surface temperature has gone up.
And that's El Nino.
And that's an El Nino. The corresponding blue dips are La Nina, which is the cooler phase of the El Nino Southern Oscillation cycle.
Yeah.
And what I'd like you to have a look at here, Al, is the peak of some of these El Nino years.
The strongest one. So there's one like in the early 80s, and this one in particular, that's 98. That's quite a famous one.
98, we will come back to talk about that, because that was a very significant event for a number of reasons.
So this is just showing that there's no set pattern to El Nino, and each one's different. The durations can be different, and it doesn't naturally oscillate El Nino straight into La Nina. It is very varied.
As you can see here, I mean, virtually El Nino state for several years in the early 90s, albeit quite weak, but just tiny
little La Ninas.
Hint at La Nina, but largely El Nino. So it's a very varied pattern.
Yeah. And of course, what we are seeing is the temperature in a specific, that's measuring the temperature of a specific part of the Pacific, which isn't easy to say. So this is where we are in the world. There's North America, there's South America, there's Australia, and there is Asia. And we're right in the middle of the Pacific, and it's in this particular box where we talk about the temperatures, the sea surface temperatures. For it to be an official El Nino, the temperatures in this box have to be above a certain threshold. Now, different parts of the world determine it in slightly different ways, which doesn't necessarily help the definition. But for the purposes of what we're going to see, it doesn't really matter, because it's in this part of the world where we're really expecting temperatures to blossom.
I think a point to make there, you're right, other organisations around the world have separate definitions, but this will be such a significant event that it will be above all of the thresholds. So there won't be any doubt. If the event happens, we will be in an El Niño. We'll know it.
And that is what we're looking at later this year in the coming months. And this is an example of what we've seen in the past. This is the 2015 example, imagery of the sea surface temperatures in January the 1st of that year, and then in November later that year. So it's quite a dramatic shift. You can see how the sea surface temperatures have risen around the equator in that area we looked at, that 3.4 area as it's known. There are other areas that you can measure, and there's lots of different reasons for that, but the main area, that 3.4 area here, you can see that rise. So that is what an El Nino looks like. Historically, that one from 11 years ago.
Importantly, I think that is the consistent area, so we have a good trend of what these events look like based on the observations from that one region.
So we're talking about El Nino, we're talking about the sea surface temperature in that area rising by a certain amount. So what are we looking at right now? What has happened this year, even in the past 6 weeks or so? This is quite a dramatic couple of images. Now, this isn't temperature. I was quite taken by this. This is imagery from space, from the satellite, from Sentinel-6, but it's actually measuring, it's not measuring sea surface temperature, it's measuring the height of the sea. Again, an anomaly of the height of the sea. It's amazing that you can get this amount of detail. And of course, a warmer sea expands. So that's what we're measuring here. So a rise in sea surface levels is indicative of higher temperature. And it's a really stark difference between the start of March here and the most recent image right at the end of March. So within a month, we've seen this area grow, blossoming of higher sea surface levels, indicative that we're seeing a warming in this part of the world.
It's quite stark, isn't it, when you look at that, to see how pronounced and well-defined that is.
That really is. Now, that isn't necessarily in the 3.4 area. That's slightly a little bit further east, actually, but it's showing you in this zone, and you can imagine with westerly winds picking up, we've seen a burst of westerly winds in this area. All that warm sea rather is going to develop more widely in this zone, in the El Nino 3.4 zone, and that is what we're expecting to see, and this is showing that really quite nicely. So this is the main bit that we're talking about. This is in that zone, Niño 3.4, that area, sea surface temperature, and this is the projection. So this is the forecast in red going forward along the bottom. The black line is what has been observed. So temperatures were slightly below average at the back end of last year, and they've been rising steadily, and they crossed the zero threshold in February, and now we're here in terms of what's been measured. But the red line is the forecast going forward when we use ensemble forecasts.
And important to say, Al, I think that these are relative temperatures to what we would get in terms of average.
Yeah.
So think of this as a rise above rather than actual values.
Yes, yeah, completely. So that zero line is the average, and anything else is an anomaly above. We're talking El Nino. Above 0.5 Celsius, that's how NOAA defined an El Nino. So we're getting into that zone in the springtime, certainly coming up, not far away. And if it was La Nina, it would be the opposite way. But
you can see what I mean, Al, by saying how definitive this will be.
Yeah.
So some organisations, 0.5, 0.8, kind of irrelevant when we get to this stage, because if it goes in line with projections, then nobody's going to deny that that's not an El Nino event.
Close to 2 degrees above average. Now, let's take a closer look at the forecast with the very most recent data from the Met Office scientists here. This is May to September. So what are we looking at here?
So what we've got here is the central estimate for the projection for what temperatures we think, or the model thinks, is going to be realistic. So you can see that by the end of August, September, we're actually pushing 1.5, 2 degrees. And you can see that that's still got a trend to go. One thing here that I'd really like to draw your attention to is the fact normally we're quite used to seeing these sorts of graphs, aren't we? We have to interpret them as part of our jobs. But look at how close that is in terms of all these different runs from the model, and they're all telling us more or less the same thing. And that is quite unusual. Sometimes you'd expect some of these ensemble members, we call them, to actually be right down here and that pattern to be more confused.
Yeah.
I can't recall it really seeing it as consistent and uniform as
that. Tightness gives you confidence. Gives you confidence,
exactly.
doesn't it? That's basically what we're talking about. So each of these individual thin red lines, hopefully you can see them there, is an ensemble. So we talk about ensembles quite a bit in the deep dive, where you run the same model with slightly different initial conditions. Again, there's videos on that we can watch. But actually these dotted lines are the more recent model runs as well. 3 of the more recent ones they run them every week. So from the end of March, the very end of March, and then the first week in April. And they're all agreeing as well as the most recent ensemble ones. All of them tightly packed together. And often when we show ensembles, as I'll do later, actually, there is much more variance, particularly with something like this, and you get those ones that spin off and it all broadens out quite a bit. The tightness of that, all indicative that we're all going to be above that threshold of 0.8 or 0.5 very rapidly, and that is likely to continue through the summer, and you know, the trajectory of that will take you further. And El Nino often peaks at the end of the year, like November, December, January is often the peak of an El Nino. So we'll have to see where this occurs. Now, there's been a lot of chat, Graham, in the press about a super El Nino. So what are we talking about with a super El Nino? Is there an actual definition?
Well, there's a little bit of journalistic license by calling it a super El Nino event. It's not a term that we're subscribing to, but it does underpin the fact that this is likely to be a significant event.
One.
And I think, you know, we get another hint from that. We've talked about the tightness of this band, but look at the height of it.
Yeah,
we're not talking about a tight band here. We're actually almost nudging the top of the graph.
So, I mean, 1 degree above the average, or 1 degree anomaly would be a fairly weak El Nino, but we're talking up to 2 degrees, so that would be classed as a strong one.
So it's likely to be, the scientists tell us that it's likely to be the strongest El Nino event so far this century.
Wow, okay.
And we're probably comparing it to a 1998
so
event.
That was the peak
I
we showed
remember
earlier.
1998. I couldn't possibly say whether you do, but...
It was a World Cup year, so I always remember those years. So 98, you pointed out earlier on that peak graph, that was a really strong El Nino, and this is comparable to that, or likely to be. And in that year, the temperatures in that area are around about 2 degrees above average in that crucial area. So it's definitely comparable.
World Cup aside, that was a really significant
and it's another
year.
World Cup year. Who won in 98? France won. Oh, maybe there's a link. We will
heard it here first.
We'll find out later. The Met Office does not advocate gambling, just to make that clear. But that's really interesting, the way that goes forward, and that is strong indication. So yes, we are expecting El Nino to develop in the coming months, and it is very likely to be quite a strong El Nino. What does that mean? Okay, the sea surface temperature in the middle of the Pacific is warming up. Who cares? Well, turns out it's quite important for a number of factors. Let's deal firstly globally and what that could mean for the global temperature, and that's what this graph is showing here, right?
So this is something I'm very familiar with in terms of dealing with global temperature. So the white line here is the actual surface global temperature for each of the years. And you see it's quite a variable line, but if you draw a trend line through that, you can see that it's increasing.
So that's climate change. From 1990 to 2023, there is a rise in the global temperature.
Indeed, but the more observant will notice that there's peaks and troughs.
Yeah.
And what we've done here is we've put an orange bar representing a year when there was an El Nino year. And you can see that a lot of these peaks actually align with El Nino years. So that's really quite important to remember. This is a temporary thing. So an El Nino will impart heat to the atmosphere and generally raise global average temperature by about 1/5 of a degree Celsius.
Right, okay.
Now,
2 Celsius, okay.
1998, we've mentioned that for several reasons, but it was a significant year for global temperature, and at the time, it was the warmest year on record.
Okay.
Now, let's hold that thought, because La Nina years, the blue lines, actually cool temperature a little bit. So you can see that there's corresponding troughs where you get La Ninas. What I want to draw your attention to, Al, is the fact record year, given a boost by the significant El Nino of that year. But look at how background temperature has risen. So by the time we get to here, the late,
20 years later, 2018.
2018.
So 20 years later.
We've got a year that is warmer than 1998, when it should be a cool year because of the influence of La Nina. So the El Nino and La Nina impart a temporary effect on global temperature.
But you can see
but
that
you
trend.
can see the rise as the temperature's coming up
That's
due
really
to
remarkable.
anthropogenic emissions.
The three most recent La Ninas are still quite a bit warmer than that really powerful El Nino back in 1998. 95 there as well, and the 2015 one there that we showed earlier from the globe of that change again. That was a peak, but the next year was even warmer still with another. And it can lag, can't it? Because it often peaks at the end of the year. Doesn't necessarily mean that year. You can have an El Nino in 2015, like this year, and if it peaks at the end of the year, it will take that temperature into the following year as well. So you often get that lag and that peak
Indeed.
effect.
So if we look at this, so we had the first 1.4 year in 2023.
Yeah, that's that. Yeah. So 1.4 above global temperature above the pre-industrial levels.
So that was the first year above 1.4. We've had 2 more years
Since
above
then.
1.4, boosted by the El Nino. We have to concede that. It's not all down to emissions. But look at the headroom. So 1.5 Paris Agreement threshold, trying to keep global temperatures around 1.5 or below if we possibly can. But look how close we are now to that headroom. And with an El Nino, it's likely that next year it will be a year above 1.5. So we'll actually see that.
And with a powerful El Nino as well, because this wasn't classed as an El Nino year, but it wasn't a particularly powerful one. We are expecting, or there's a very good chance that this year will be a powerful one.
It's way too early to call it a record year for next year. But if all of these things happen in line with the forecasts and projections, and that there isn't a massive volcano which would help, eruption that would help suppress global temperatures, it could be a record year. And our experts are saying it's likely to be a year above 1.5.
Wow, okay, so watch this space. Again, you heard it here first. That's really interesting on a global perspective, but also El Nino has quite dramatic effects regionally, doesn't it, across the world. So let's take a look at that. Now, apologies in advance for my poor drawing on this, but I have scribbled out, and it really is a very quick scribble, some of the areas across the world that are affected by this. Because as you can imagine, what we're talking about is, I'll zoom out a little bit more so you can see the world a little bit better. We're talking about temperatures in this area, sea surface temperatures rising, and that has all sorts of implications and effects around the world, changing the distribution of rainfall, because instead of the warmth being over here and rising air and you've got a lot of wet weather, actually what happens is you get drier conditions in Australia, in the east of Australia, and it's the areas closest to that El Nino zone that are affected the strongest, as you would imagine.
Can you just go back a sec, Al, to the Pacific? Because I just want to draw attention to something here. So we're saying that the El Nino will have an impact in this region, but when you look at that hemisphere view, there's hardly any landmass within it. It's all ocean. So this is an event that happens possibly farthest away from the majority of human population, but has such a significant impact on people's lives around the world. I think that's really something that we should draw attention to.
Very, very valid point there, Graham. Interesting to see the globe from this perspective, particularly with people coming back having the Artemis imagery that we saw recently as well. So it's happening in this part of the world. I should have said that my drawings actually, the yellow in here are areas of the world that are dry. In an El Nino year, become drier than average. You see a drying effect in the yellow areas, and the blue are areas that are wetter than average in an El Nino year. Now, the areas, as I said, that are closest to this zone are the areas that are most affected. And what we see, and again, I'm not going to go into the details of the meteorology, that's in a separate video, you can find out more about that, but roughly speaking, you get less, because it's not as warm here, you get less ascents, you get less thundery showers in eastern Australia, so it's It's drier in Australia and right across Southeast Asia. It's drier in an El Nino year.
Certainly Southeast Asia, the Western Pacific generally, Eastern Australia and Indonesia can all expect, on average, drier conditions.
Now, again, part of my drawing, we'll probably put the link again in the chat about the actual maps, the scientific maps, because I've just kind of scribbled these on. But India, again, highlighting that as an area that's drier than average in an El Nino. That's so important because the monsoon rains, provide so much of the infrastructure to India. So
important
vital
for crops.
So important for crops and everything. So drier than average here. Central parts of Africa tend to be drier than average, along with much of Southeast Africa. And then we're back to South America, where some of the biggest impacts are felt because we're closest to the actual event, and a large swathe, northern parts of South America into Central America, are drier than average in an El Nino year. Now, again, important to stress, not just my dodgy drawing, but different parts of the world are affected at different times of the year. It's not like for the whole year it's drier than average, different parts. And again, we'll put the full maps in the chat. But this could be quite important, couldn't it? Because drier than average in this part of the world.
So the region covered by your yellow highlight there is the Amazon.
Yeah.
Clearly a very important place, not just within the regional context of South America, but globally. Controls a lot of the global climate, actually. It's a bit of a brake on the climate. So when you've got drier conditions in Amazonia, and you've also got elevated temperatures likely in the region, we know that this region is already extremely fire prone. So we're not making any predictions here, but if the trend follows through, it's exceedingly likely that we're likely to see, on balance of probability, more wildfires in that part of the world.
And that's really significant, isn't it, for it's a cycle, isn't it? It's a positive feedback loop, because if you burn more of the trees, they're not taking out as much of the carbon dioxide from the atmosphere.
Absolutely, and you're putting more carbon dioxide into the atmosphere, so that could be disastrous on a number of
another highlight. So yes, I just wanted to do a bit more drawing, because I always love drawing on it. So this area is also warmer than average. So the red now means warmer than average, and if we go around the world, and again highlighting these areas that are drier than average, if you check the map, you can also see that actually large parts of southern Australia are warmer than average in an El Nino year, along with Southeast Asia. These are pockets, again, where you've got that overlap of not just drier than average, but also warmer than average conditions in the southeast of Africa also. So it has a number of effects. They're not always, as direct every year. Every El Nino is different in terms of its intensity and how widespread it is, but also the actual knock-on effects, because it's obviously a very complex system. There are other global drivers affecting it. But the closer you are, as a rough guide, to the actual warming of the seas, the more direct the link is. Talked about wildfires, and one area that has suffered from wildfires recently, California. Interestingly, in El Nino year, California gets more rain on average.
So there's a possibility that could certainly help the forthcoming fire season by creating more rainfall, keeping conditions wetter, perhaps preventing more of the ignition of the forests and suppressing any fires which do break out. Again, not a forecast, but looking at general trends and probabilities, that's likely to happen. Another possible event that could be connected to El Nino is the suppression of Atlantic hurricanes.
Yes.
So very important this time of year. Everybody wants to know what the forthcoming hurricane season is going to be like in the Atlantic basin. Obviously affects and impacts in the Caribbean and wider, but you'll know more about the meteorology of this than I. But
yeah, interesting that the seas obviously play a huge part in that, but actually it's often more to do with the wind shear that prevents, when in El Nino year you get more wind shear in the Atlantic basin, and wind shear kind of breaks up hurricanes and stops them from forming. So that is an area where you would expect in an El Nino year, if we're going to get an El Nino year, you would see fewer storms. But by contrast, and as I'll talk about later, with warmer seas here, it fuels more storms in the Pacific. But let's quickly just go back, because I've got quite an interesting graph to show that rainfall in Southern California. And in an El Nino year, this blue line, so we're going date along the bottom here, the wet season tends to be in the autumn into the early winter, early spring. That's the rainy season in Southern California. And this would be a typical year. And in an El Nino year, you tend to get this. So you get heavy rain. Often you get the 100% the annual rainfall by mid-February, because you're above that, where it gets very dry very quickly. So with an El Nino, perhaps speaking later this year, it may not have an impact on this fire season. It potentially have more impact on next fire season, because it's more likely to influence the rain as we go into this autumn and the next spring. But just quite an interesting example there of how El Nino directly does affect the weather in other parts of the world. We are always going to get asked this question. We get asked this question quite a bit. So I need to ask you, Graham, what about impacts for closer to home? What about for the UK? Does El Nino mean anything to the UK?
So clearly you've mentioned that El Nino happens in a region of the world that's almost as far away from Europe as you can get, really, in the tropical Pacific. There are sometimes observed teleconnections between what happens in an El Nino year and what happens in the UK's weather. But what I would say to you, and I don't know why I'm telling you this, because you know this better than anybody, the influence of El Nino is a significant driver in global weather and in our weather, but it's not the only one by any means. So we're often using this analogy of European weather as a bit of a battleground with all these various influences coming in. It's possible that we could see some impacts from El Nino, but equally possible that we could see other drivers being more dominant, even though we've referred to the fact that this is a significant event. So it's way too early to say what this is going to mean for a British winter or a Northwest European winter. We will have to do a lot more understanding and forecasting to know how strong those other drivers are in terms of how all those different entities will interact with each other, and the consequence of that is what we get in the weather forecast.
Absolutely, thank you, Graham. Well put. And there are, if you want to know what all those drivers are, things like the Atlantic Oscillation, North Atlantic Oscillation, the Arctic Oscillation. There's all kinds of different drivers. The quasi-biennial variation as well. There's a whole video all about them. So we're going to make sure Rich is really busy by telling him to put the link to that in the chat as well, because we made a whole video about. I think it's on presenting it about all the different drivers, of which El Nino is just one. And as we mentioned, the closer you are to El Nino, the bigger the effect is, and it's a long way from here. So the links, there are some, but they're weak at best. Graham, thank you so much.
Thank you.
Really enjoyed this chat. I hope you have enjoyed it as well. But thank you very much for joining me on this week's Deep Dive.
Pleasure. Thank you.
Always fantastic to talk to Graham on the Met Office Deep Dive, such a knowledgeable chap. And really interesting stuff there about El Nino. Right, let's get back to the UK's weather, because it's fairly typical April fare through much of this week. Spirals of low pressure not far from the UK, further brewing out in the Atlantic as we've been through this week. And this one in particular, an area of low pressure that will control our weather in one form or another over the next couple of days. What's going on? What's the bigger picture? Let's show you the jet stream. This big dip in the jet stream, and that's that low pressure we saw a minute ago on the satellite image. And because it's kind of in this dip, in this trough, it's not really doing very much, not really interacting with the jet stream. The whole system is kind of just bodily moving from west to east, and these old weather fronts are then, as a result, kind of flinging out across the UK, bringing a lot of cloud and some outbreaks of rain. The whole package does move a little bit closer, so we'll see some heavier rain on this cold front in particular as it crosses the UK tomorrow. And then, there's another little low waiting in a similar position, but if we stop it there, by the time we get to Wednesday, the jet stream's kind of weakened. It's not as developmental, it's more in a straight line, still a bit of a dip, so still some intensity to this low pressure. And as that develops and comes in, again, notice you can't really see the pinks anymore. The jet stream has weakened, but it's still a fairly intense area of low pressure with weather fronts that are going to bring us another spell of wet and windy weather, particularly the closer you are to that low as we head into Friday. And then notice the jet stream's kind of broken, fragmented, and look at this. little area of high pressure potentially toppling in as we go into the weekend. High pressure means sinking air, a lot of dry weather, and potentially some sunshine, particularly for Sunday if it does crop up. Before then, though, plenty going on. Just rewind the clock, because if we just zoom all the way over to the United States, I just want to show you this, because there's two jets across North America being greedy. Of both the jets kind of coming together. You often get two jets across the US because it's such a large landmass, US and Canada, I should say, shouldn't I? North America. But the fact that the two jets are kind of coming together, the polar front jet and the subtropical jet coming together, is quite unusual. That's not just one jet splitting, that's two jets getting very close together. That's quite an unusual setup and is driving a bit of the uncertainty as we head towards the weekend. More on that in a moment, because as I said, low pressure systems coming our way for the next couple of days. So what can we expect? Well, I mean, I called it April showers in the week ahead forecast, which if you're a meteorologist, you should be shaking your head at me, because it's not really April showers, because this is more frontal rain coming in. But because it's fragmented and people see a bit of rain and then it stops and a bit of rain and then it stops, I was quite happy to call it showers because it's kind of a bit more on and offy. But technically speaking, not really showery, because as I say, these are our weather fronts that are moving in, bringing a lot of cloud and some outbreaks of rain, particularly if we go back to tomorrow and zoom in a little bit, just show the UK. There's that cold front coming in. A bit of anger to that, a bit of angst because the jet stream's just getting that a little bit closer and the low's a bit more developmental. So some heavier rain coming in for a time as we go through tomorrow across Wales, southwest England. A spell of rain will then work its way across the UK during the day. But ahead of it, some warm air tucked in here. So if you get a bit of brightness in eastern areas, it will be quite warm tomorrow before this rain band spreads its way through, which, as I say, could be on the heavy side. Then Thursday's a drier day. Yes, a few showers here and there, but we're kind of between those two weather systems. And then that next one comes in on Friday. But again, notice parts of the east maybe not seeing too much. It's all because the lows here, everything's orientated around that way. So a lot of the rain bands coming into the areas that see a lot of rain. So Wales, southwest England and western Scotland, along with Northern Ireland. If you did watch my week ahead video yesterday, I showed the accumulations of the rain through the week, and it was always those western areas that saw the most, with just a few showers at times getting into the east. So that sets us up for the next few days, the rest of this working week. After that, well, uncertainty does grow a little bit, but as that system moves through, you can see it there. Let's put it on the broader picture again. Fast forward to Saturday, and there's that low coming in for Friday, bringing some wet and windy weather. But for Saturday, it's still there across Scotland, bringing some outbreaks of rain, cold front to clear through. Weak jet stream though, and that's when the high pressure starts to topple in. So there are quite strong signs that we will see higher pressure building in for Sunday across the south. So southern areas seeing high pressure. Again, high pressure means the descending air, so the winds will be lighter, and there's a good chance of seeing some sunnier skies, at least for a time through the weekend across the south. But with this low here, sitting still across Scotland, that would still be producing quite a lot of cloud and quite a few outbreaks of rain for Sunday. Fast forward to Sunday. According to the Met Office model, at least, still a lot of showers across the north, drier and sunnier in the south. Not particularly warm though, temperatures still only in the mid-teens in places. So that's an area we need to watch, because not all the models are agreeing with that pressure pattern. High pressure to the south, low pressure to the north. There is a little bit of uncertainty, which I can show you by looking at the European model. ECMWF, what does it think is going to happen at the weekend? It's similar. Where we got? This is Sunday. Now look at this. For Sunday, the European model has the high sitting right over us. No low near Scotland. So that would mean dry and fine and generally sunny weather for pretty much all parts of the UK by the time we got to Sunday. So a bit of a discrepancy there. Not all of the ensemble members are showing this, but many of them are. We can probably pick out quite a few. So if we look at number 3, again, that's got high pressure. So the ensemble is when we run the model with a slight tweak at the start. And these are the European ensemble models. That's number 8. A lot of them have high pressure in and around the UK for that same time period for Sunday. But we can probably pick out one or two that do have something similar to the Met Office model. There's the low pressure sitting across Shetland at this time, which would still generate quite a lot of showers across Scotland. And there are a couple more. There's number 14's got low nearby, 15, well, if you squint a little, there's a low pressure there. But most of them do have that high pressure, but there's 19, it's still got low pressure, but it's a little further north. So quite a strong signal that high pressure is moving in. The Met Office model perhaps a little pessimistic with that low sitting still across Scotland. See the European model a bit more bullish about when that high pressure moves in. Why the discrepancy? Not a huge discrepancy, you know, not unusual to have that amount of difference at this lead time. This is Sunday, recording this on Tuesday, so that's 5 days. So there's nothing unusual, but I just thought I would show one of the reasons or where that discrepancy is coming from, perhaps, because that's quite interesting, relating to what I talked about earlier with the jet stream. So this is, there's the UK in there, and this map is showing the difference between the EC European model and the Met Office model, high up in the sky, around 10 kilometres up, at the 250 hectopascal zone. So, and the areas, it's basically showing that the pressure pattern high up in the sky, around about 10 kilometres, and the black line, the dotted line are the two different models. But crucially, what you can hopefully pick out are the blobs, the blues and the yellows. You take one away from the other, and that gives you the difference. So this is showing the difference between the Met Office model and the EC model. If they were the same, you wouldn't get the blue blobs or the yellow blobs. So where you've got differences, that's where the blobs are showing up, where there are differences. And by the time we get to, this is Friday, so this is in that development zone, out, there's the UK, and these kind of 4 quite significant blobs at this stage are where the models aren't agreeing. But what was interesting, and I must thank Mark, the Deputy Chief, for pointing this out during the morning brief this morning, is where that's actually come from. If we go back, so that was for Friday, this is for today at 6 p.m. this evening, Zulu time. And this is again showing that same thing, but there's now much more agreement. Yeah, there's a bit of a paler blue zone down there, but much more agreement generally out across the Atlantic with the UK here. But this is where that error stems from, or that's where the biggest difference is at this stage. And if we play through time slowly, so if we forward it on to tomorrow, is it going to play through? Or there you go, that difference translates and it moves out across the Atlantic. And keep your eye on that and we can track it, and that is basically where that difference comes in as we head towards Friday and then into the weekend, which is ultimately responsible for that difference in the way the models are handling the high pressure and the low pressure and how quickly it comes in. And it originates, you can track it back, and it originates, those differences, you can track them back to that part of eastern Canada. In fact, I'll just scroll back on here. There we go. Hopefully that's going to do it. Oh, it's gone very slow. Come on, you can do it. You can do it. Let's go that way. And I'll just come back to it that way. And then you can see, oh, why is it not behaving? There we go. That's what I wanted to show. This is where we're at now. And it's that difference. You can trace it back to that difference across eastern Canada, which goes back to that funky jet stream, or the two jet streams kind of coming together in an unusual formation. So there's the two jets coming together like that, being so close together. That's not a splitting jet, that's two different jets coming together, being so close. So that is where the area of uncertainty generates from, and you can see why when you've got that quite unusual setup. Obviously the models are better at handling things when they see them more frequently or more typical positions. So that is where the potential discrepancy around the weekend comes from. So I just thought I'd show you that because it was quite interesting. Again, thanks to Mark, our Deputy Chief Meteorologist, for pointing that out this morning in the brief. Obviously, we'll have more on the weekend's weather and into next week in the 10-day trend tomorrow with Annie. So another reason to subscribe, and then you won't miss that. And while you're there, if you're enjoying this, do hit that thumbs up. It does make a big difference. Thank you very much. One more thing to talk about, which is kind of linked to El Nino earlier. We talked with Graham about the developing El Nino. We saw how the sea surface temperatures already starting to develop in parts of the Pacific. And one thing that El Nino does tend to do, it suppresses hurricanes in the Atlantic, but it encourages more tropical cyclones in the Pacific, and that is what we're seeing. And this is a particularly powerful storm, Sinlaku. If you look closely, you can just about make out the Mariana Islands in there. You have to look and get the right frame. This is on Tropical Tidbits. This was from this morning. There is a more up-to-date one that I saw just before I came and recorded this, but you can go and find it for yourself if you go to Tropical Tidbits. It will actually be crossing now, the storm crossing the islands if it hasn't done already, and you can see that the eye of the storm going across the Mariana Islands. Significant impacts from this storm. This is a powerful storm, equivalent to a Category 4. It's called a large because of its size, but violent because of the strength of the wind. Average winds, sustained mean winds 120 miles an hour. So yeah, equivalent to a Category 4. Weakening a little bit as it tracks northwards. It's going to still be that Category 3, Category 4 as it tracks its way over the next few hours. Those kind of winds are likely to cause damage. Now this part of the world, where are we? Let me show you that because that might help. Doesn't really see it on there. Let's zoom out. Head around to the other part of the world, quite easy to spot it. That's where we are. So there's Japan, there's Australia, there's the Philippines. So we're in this part of the world where we saw earlier that sea temperatures have risen, and that again is part of the reason feeding these big storms. There was another one on the southern side of the equator that's died out now, but this one is particularly intense, particularly lively. If we zoom right in, can you see those islands? Yeah, just about. There's Guam. And then there you're into the northern Mariana Islands in there as this storm is crossing as I record this right now. Very powerful storm indeed. Those winds 120 mile an hour, that's the mean wind speed. Gusts are going to be larger than that, so we're expecting structural damage. It's also going to drop a lot of rainfall. 500 to 600 millimeters of rain could fall. Now, most of it's going to fall over sea, but if the islands get that kind of amount of rainfall, that is going to be significant, likely to cause mudslides, and there'll be large waves associated with this storm as well. So we are expecting some significant issues from this storm system. This part of the world obviously gets quite a lot of tropical storms, but not necessarily at this time of year. This is very early in the season for such a powerful storm. Paul on our global guidance upstairs, again, one of the meteorologists here, he was saying they've had a similar storm, but that was late in April, but it was later in the month. It's very unusual to have such a powerful storm hitting this part of the world. 500 to 600 millimeters of rain. That is the equivalent to what London sees in a year. So, you know, in a day or so, they could have the same amount that London or the southeast generally receives in a year. So that is, again, likely to cause some problems and some mudslides along with those powerful waves. What happens to it next? Well, it kind of migrates slowly northwards and will eventually start to weaken, but it maintains something of its strength, certainly for the next 36 to 48 hours. And it will affect the more northern parts of the Mariana Islands, the less populated areas. But there are still, you know, thousands of people living on these islands. So this is significant storm affecting this part of the world before it kind of weakens a little bit as we head later in the week. Let's fast forward a little bit. You can see it filling a little bit and then drifting northwards. If I put it on during the day, then you can see the islands a bit better on there as well. So there we are, crossing here, going then, but still affected. It's quite an unusual path, very close to all of the Mariana Islands. So that's quite unfortunate that most of the islands are going to be affected by this storm with the heavy rain or those strong winds. So that is something we'll obviously be tracking very carefully. I say you can go and view those images for yourself, the eye of the storm actually going across. Right, that's about it, I think, from me for today. Again, thank you to Graham, thanks to Mark, thanks to Paul from upstairs, from the guidance unit for their words of wisdom also today. I hope you've enjoyed it. As I say, if you have, please let us know in the comments, but also do hit that thumbs up button, the like button, and spread the word. Let everyone know that the Met Office is here doing weathery things every Tuesday. Join us for the live on Friday. It's Annie and I doing it this week, and Annie's got the 10-day trend for you tomorrow as well. But from me, for now, goodbye.